Check, 1, 2. All right, here we go. We got optimization. We're going to, of all the numbers whose sum is 230, find the two that have a maximum product. And in other words, we're going to maximize q equals xy, where x plus y equals 230. Some of you guys have found a shortcut for this particular problem. But if we're going to do this as if it's just a plain old max problem, we're going to try to maximize q. So to maximize q, I'm going to replace y. Looking at this, I can see that y is the same as, let's see, x minus 230. Actually, let's turn that around. Let's do that easier. Subtract x from both sides. Y is the same as 230 minus x. So if I replace that here, q is the same as x times 230 minus x. If I multiply everything by x, 230x minus x squared is what q is. Q prime then, looking for a derivative because I'm trying to find a maximum. A maximum is going to happen at where the slope is 0. So if I take the derivative here, I get 230 minus x. 2x. Thank you much. Thank you much. So this will equal 0 when x is what? 230 over 2 or 115, right? So when x is 115. Now, if I take the second derivative of q, I get what? Negative 2, which is negative for all x, which means this thing opens down. It's concave down, which means it has a max. So this is concave down for all x, which implies a max. So one of the numbers is 115. The other number is 230 minus 115, so it's also 115. So we're done right there. Any questions on number 1? Of all the numbers whose difference is 4, find two that have a minimum product. Well, that difference, d, would equal x minus y, or x minus y is equal to 4, right? Actually, let's back up. X minus y equals 4. There's two numbers that have a difference of 4, right? They have a minimum product. The product is going to equal x, y. I want that to be minimized. Well, what is y? Well, x minus 4 is the same as y. So my product can be written as x times x minus 4. X times y. My product can be written as x squared minus 4x. Now I know that the derivative of my product is equal to 2x minus 4. When does this equal 0? When x is 2. If I take the second derivative, I get 2, which is positive, so it's concave up, which implies a minimum, or minimum value. So one of the numbers is 2, the other number is 2 minus 4 or negative 2. So it's 2 and negative 2. All right, number 3, we've got the velocity of a particle, v, time t is in seconds. Find the time at which the velocity is a minimum. So this is like 1 and 2. They're giving us a function, and they're saying find the time where this is a minimum. If I want to find a minimum, I've got to do a derivative, because I'm looking for a horizontal tangent here. That's where my mins and maxes can occur. The derivative of v is 2t minus 3. This will equal 0 when t is 3/2 or 1.5. If I look at the second derivative would be 2, which is concave up, which implies a, that's a funny looking U, which implies a minimum. So this happens at the time t equals 1.5 seconds or 3/2 seconds. And that's all we need for number 3. For a company wishes to manufacture a box with a volume of 44 cubic feet, it's got open on the top. It's twice as long as it is wide. Find the width of the box that can be produced using the minimum amount of material, around to the nearest tenth if necessary. So let's draw us a little box here so that we can label it and organize information. So it's twice as long as it is wide. So let's call it x wide and 2x long. And then the height is unknown. But I do know the volume is 44 cubic feet. So that's all the given information. What am I trying to minimize? I'm trying to minimize the amount of material, which would be the surface area of the box. Well, I'm going to call the surface area M for material. So my surface area is M. I have the bottom surface, which is 2x times x, or 2x squared. I have this side piece right here. It's 2x by h, but there's two of them. So one of them is 2xh, two of them would be 4xh. And I have this front piece, which is x by h. There's two of those, so one of them is x by h, two of them is 2x by h. I can clean this up a little bit and say that m is equal to 2x squared plus 6xh. The problem I have with this function is I don't know what h is in terms of x, and I don't want to do this derivative with two variables if I don't have to. And I don't have to because they gave me some information over here about volume. They told me that the volume is 44, but the volume is also length times width times height, right? So the volume of 44 has to equal 2x squared h. If I solve that for h, I would divide both sides by 2 and x squared. That would give me 22 over x squared is the same as h. That value for h is going to go into this equation for m, replace that value for h. So let's go ahead and write that. M is now 2x squared plus 6x times 22 over x squared. So notice the x squared and the x are going to get to reduce. And we're going to end up multiplying 6 times 22. So I got m is equal to 2x squared plus 6 times 22 is 132. If I reduce, that'd leave me an x on the bottom or a negative x on the top. Or x to the negative 1 on the top, I should say. So here's my function. It took me a long time to get here, but I finally got the function that I need to minimize. Number 3, they just gave us a function outright. In this problem, I had to do a lot of work to get to that function. Now the rest of the process is the same. I just need to find a derivative. So let's go find a derivative. Derivative of m is going to be 4x minus 132x to the negative 2. We need to find out when that thing equals 0. We need to find out when that thing equals 0. That thing equals 0 when 4x is equal to 132 over x squared. Agreed? So when these are equal, they're going to subtract and make 0. Right? If I solve for that by multiplying both sides by x squared, I get 4x cubed equals 132. X cubed is equal to 33, and x will equal the cube root of 33. The cube root of 33, according to my calculator, is approximately 3.21. Okay? So, is this a max or a min? Well, let's just look at the second derivative real quick and see if we can determine that. The second derivative would be 4 plus 132x to the negative 3. Would you agree that this is positive for all positive x's? This is going to be concave up for all x greater than 0. It's positive for all positive x's. Therefore, we're looking at, concave up, we're looking at a minimum. That implies a minimum. So this answer has to give us the x value that would give us a minimum. So what does it say? Find the width. Well, the width is the x that we just found, so it's about 3.21. And what's our feet? Our units is feet. So there we go. Properties of integrals. Number 6, we're given this fact. The integral from 6 to 8 of some function is 5. 2 questions. What's the integral from 5 to 5 of the same function?
0.
0. What's the integral from 8 to 6 of the same function?
2 more than 0. Well, that would be 2.
Negative 5.
Oh, right.
It's just the opposite of 6 to 8's direction, so we get the opposite answer. Number 7, some integral from -7 to -4 of gt is always 12. So let's do both these. Let's do the easy one first here. What's the integral from -4 to -7 of the opposite of g?
12.
That's going to be 12. Because it negated twice, right? We flipped this around, so that makes it negative. But then we got another negative, so the double negative is a positive, so it puts us back where we were. The first one, if I take from -7 to -4 on the integral, and I do g of x of that, but I also divide that by 12, what is that going to give me? 1. 12 divided by 12 is 1. This 1/12 is just a multiplier. So it's going to be 1/12 of what it originally was. It's going to be 1. Number 8, we're given some information. From 7 to 11 of f of x dx is -4. From 7 to 11 of g of x dx is 8. So what is 7 to 11 of f of x minus 5 gx dx? No. -44. How do we get that? We take f of x, which is -4, and we subtract 5 of these. So -4 minus 5 times 8, -4 minus 40 is -44. And we're done. Go ahead. Number 9. We're going from -4 to 4. F of z dz is 0. But -4 all the way to 5, f of dz is 8. So the question is, what's the opposite from just 4 to 5 of 4 times f of x dx? Well, how far is it from 4 to 5 all by itself? 8. And if I multiply that by 4, I should get 32. But if I take the opposite of that, I better get -32, and that's where we're at.
Weren't these the exact same ones that were on?
A particle starts at x equals 0 and moves along the x-axis with a velocity of 0.2. Find the time t greater than or equal to 0 where the particle is at. Where is the particle at? T equals 9. What do we get? 1.8. How'd you get that? Rate times time equals distance. We've got a rate of 0.2. We've got a time of 9. 9 times 0.2 is 1.8 whatever units. Done. Number 11. A particle moves with the velocity of v of t equals 2t plus 7. This is a little more interesting than the other velocity because it's actually a function and not a constant. Find the distance traveled between 1 and 5. What do? Just integrate it from 1 to 5. We've got a velocity function. If we want to get a position function, we have to integrate to get from velocity to position. So I integrate v of t dt, which is equal to, what's the antiderivative of 2t plus 7? T squared plus 7t. And we're still going from 1 to 5. So if we plug in 5, I get 25 plus 35 minus, if I plug in 1, I get 1 plus 7. So I've got 25 plus 35. That's 60 minus 8, which is what, 52?
I haven't done that lesson yet, but there's an exact answer.
Here we go. Let's do some integration. What's the antiderivative of cosine? Sine x. What's the antiderivative of 6? 6x. And we're going from negative pi over 2 to positive pi over 2. So we're going to plug this in. Sine of 90, sine of pi over 2 is 1. Plus 6 times pi over 2 would be 3 pi, right? Minus sine of negative pi over 2 is negative 1. And then 6 times negative pi over 2 would be negative 3 pi. So I've got 1 minus 1 is 2. And I've got 3 pi minus a negative 3 pi, which would be 6 pi. So it's 6 pi plus 2 is the exact answer. We'll stop right there. Here goes number 13. What's the antiderivative of 2x to the third? What's the antiderivative of negative 5x to the negative 2? Let's see, if we add 1 to negative 2, we get negative 1. Divide by that, it gives us a positive 5. Okay, good. And then we got from 1 to 3, right? Plug in 3, I got 81 halves. Plus, plug in 3, I got 5 thirds. Minus, plug in 1, I got a half plus 5. It's just a matter of figuring out what that equals. That's about 36 and 2/3, or 36.67-ish. There we go.